Okay, folks, section 9.4, it's solving linear systems, the addition or subtraction method. Now, yesterday we focused on the substitution method, and that works great for us. But sometimes, it might be easier for us to use what's called the addition or the subtraction method, because substitution may give us some big fractions or some funky looking fractions that make it difficult for us to substitute. Not impossible, obviously it's going to work every single time, but sometimes it's easier to use a different method, okay? So we're going to talk about this one today. Some people call it linear combinations, some people call it the elimination method. This book calls it the addition or subtraction method, okay? And so let's look at the first example here. It's called the addition method, and they've given us two equations, okay? Now, remember with substitution, I like to put them side by side, but when I'm using the addition or subtraction method, I want to put them right on top of each other, okay? And I have to have them in what's called standard form. I don't have to have them in standard form, I have to have them in the same order, okay? So if you look at these two equations, they both have the x terms first. Okay, let me get that thing out of the way. They both have the x terms first, they have the y terms second, and then they have the numbers over here by themselves, okay? And that's called standard form, whenever we have the x, then the y, and it equals a number, okay? We want to make sure that we put them in that order if we're going to use the addition or subtraction method, okay? Now, how do I know if I want to use the addition or subtraction method? Well, I'll tell you this. Look at each of the variables. In front of the x, there's a 5 and a 3, okay? Now, they're not the same. So, what I'm looking for is the same coefficient or opposite coefficient in front of the variables, okay? In front of the x, there's a 5 and a 3. So if I add those, I get 8, and if I subtract them, I get 2. And it doesn't cancel out. I'm looking to cancel out one of the variables, okay? Now, with the y's, you'll see I've got a -1 and a +1 in front of the y's. Now that's good, because if I add a -1 and a +1, they just cancel out and go away. So this is how we would write it, okay? We'd write it as 5x minus y equals 12. I'm writing it a little bit bigger. 3x plus y equals 4. Some of you guys were talking about this yesterday. I know Jordan K. was talking about it yesterday. And here's what I do. I make it kind of look like an addition problem. But I'm going to draw columns here, because remember, I can only combine things that are alike. I can only combine like terms. Now in this case, I want to add them because they're opposite signs. And those, when I add those opposites, they'll cancel out. So 5x plus 3x gives me 8x, right? And -1y and +1y, when I add those, they just cancel out. And when I add 12 and 4, I get 16. So now I've got 8x equals 16. Divide by 8, and x equals 2. It can be a lot easier sometimes to do the addition or subtraction method. Now, what I still need to do is get the y, so I'm going to plug it back into one of the equations. It doesn't matter which one. I'm going to take the first one there. 5 times, not x, but 2, what x equals, minus y equals 12. 10 minus y equals 12. Subtract 10 from both sides. -y is equal to 2, so y equals -2. So my point, where those two lines would meet, are 2 is 2, -2. Perfect. Now let's review a couple of things. Look at each of the variables. Look at the x variables. Do they have the same number in front of them? No. Look at the y variables. Do they have the same number in front of them? Yes. Okay, are those numbers opposites of each other, or are they the same? They're opposites of each other. Okay, if they're opposites of each other, then I want to add them, because that'll make them cancel out. Okay? All right. Let's try another one and get a little more familiar with this. Good job.